Hello. This is a lesson that I would normally teach in class that is to cover factoring and the way to approach a factoring problem so that you can solve it in the simplest and most accurate way. To follow this video, I recommend you print out the 14.6 class notes keys from course documents. This video series is in 4 parts. The first part is what we're doing, actually 5 parts. The first part is a general introduction to factoring, and it shows you the steps you need to go through as you decide how to factor a problem. So in 14.6 key, we'll begin on page 1. When you are looking at an expression you need to factor, before anything else, well, there are 2 things you should actually do at first. One is to look to see if there is a greatest common factor that it is possible to factor out, and if so, factor it. But before you do that, you need to check to see if there are perfect squares involved in the expression. If there are, you may want to skip down to one of the special cases, which I'll talk about later. But let's assume there aren't perfect squares involved. Then here are the special, well, first we're going to deal with greatest common factor. But after you have factored out the greatest common factor, which I'll talk about in the next video, then you're going to look at special cases. And special cases include difference of squares, sum or difference of cubes, and perfect square trinomials. So in number 2, we have look at the number of terms in the remaining polynomial. If there are 2 terms, if it is a binomial, like a squared minus b squared, then you have to ask yourself if it's a difference of squares. If it is not a difference of squares, then it is factored already. But if it is a difference of squares, then there is a formula you can use for factoring it. So a squared minus b squared equals a plus b, a minus b. And what that means is you find that the first and second terms are perfect squares. You find what the square roots of those terms are, in this case a and b, and then you add the roots and subtract the roots. Add them and subtract them, and those things get multiplied together. That's a difference of squares. A sum or difference of cubes is, for instance, if you have a perfect cube and a perfect cube, the formula is a cubed minus b cubed is a minus b times a squared plus ab plus b squared. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. And I'm going to show you a way to remember those formulas. I recommend that at the beginning of your exam you write down all of the special case formulas. When you're writing the formula for the sum or difference of cubes, the first thing you write down, and you have to memorize this, is a, leave room for the operator, then b, then a squared, a, b, and b. And you do this exact same thing for both of them, the sum and difference. Whoops, I forgot the squared here, and b squared. So your job now, and this part you have to memorize, and notice the middle term here is ab. It is not 2ab, which is a common error. Okay, so now you have to figure out what operators go in there, where the pluses and minuses go. So you start with the last sign. Here is always plus. The last operator is always plus. Okay, now let's look at the sum of cubes. You will always have a plus or a minus in these 2 places. It just depends on what order to put them in. So remember, whatever this is, this will be the opposite. And same here. So When you have a plus here, you write a plus there. And when you have a minus, you write a minus. So that means that up here you have the opposite of a plus or a minus, and down here you have the opposite of a minus or a plus. So that's how you remember the formulas. If it isn't a difference of squares, a sum of cubes, or a difference of cubes, then you ask yourself, is it a perfect square trinomial? Before you go to this, notice a difference of squares, a difference of cubes, and sum of cubes are all binomials, meaning they have two terms in them. So that's a clue to you. If it has two terms, you may be able to factor it using one of these three formulas. However, in the difference of squares, notice there is no formula for sum of squares. That's because a sum of squares, a squared plus b squared, is prime. It cannot be factored. There are questions on the exam and homework that test you on that. So you might get a problem like x squared plus y squared, and you might be tempted to write down x plus y, x minus y, and you would get it wrong. X plus y squared is prime and cannot be factored. It is already factored. So keep that in mind. Now let's look at perfect square trinomials. They look harder to deal with, but they're really not. If you have a perfect square, you have a trinomial, first of all, it has three terms, and this term, the first and the last, are perfect squares. Then you have to look at the roots of them, a and b, and ask yourself, is the middle term 2 times a times b? If it is, you can ignore the middle term and simply write the sum of the roots, all of that, squared. If it's a squared minus 2ab plus b squared, then it's the difference of the roots squared. We will work examples of that in the video on perfect square, on special cases. But what if it's not a special case? If it's not a perfect square trinomial, you've looked at your binomial or trinomial and you don't see any perfect squares. For the binomial, if there are no perfect squares, then you're done. But for the trinomial, now you look at the first term in the trinomial. Is the lead coefficient 1? Coefficient means the number in front of the x squared term, or in front of all of the terms. Like here, the coefficient is b, whatever number that is. In x squared, you see no coefficient. That means there's a 1, which you don't have to write. So in this case, the lead coefficient is 1. If it is 1, then you do what is called reverse FOIL. And I will demonstrate how to do this in the reverse FOIL video. But what if there is a coefficient that is not 1 in front of the x squared term? So now you have a situation where, in this case, they put the letter A. It could represent any number. It could represent 4 or -7 or whatever. But if this coefficient is not 1, then you need to use a technique called grouping. And grouping helps you to resolve the situation where your lead coefficient is not 1. Okay, the final case, and I'll put this with grouping on the grouping video, is if you have 4 terms, then you should try factoring by grouping. So let's look at these problems, and all we're going to do, we're not going to solve them, we're just going to decide what method we are going to use. So in the first problem we have 8m squared p squared plus 4mp. Now, is there a greatest common factor? And yes, you can take a 4 out of both of these terms, so there's a 4, and then you can take an MP out of both of these terms. So if you have two m's, for instance, you take the one with the smallest exponent and remove that from the equation. So you would factor out the 4MP. So that's a greatest common factor problem. In this scenario, you have 5x times a plus b minus y times a plus b, and there is a common factor again. The common factor is the binomial a plus b. So in factoring, you want to always put parentheses around your binomials and treat them as one term. So when you factor out a plus b. In this term, you do not have a common factor. There are no perfect squares. So you go on to step 3, which is it, or step 4, I don't remember. But anyway, is there a coefficient here other than 1? And there is not. So in this case, you would use reverse FOIL. In this case, no greatest common factors. It's not a binomial. Is it a perfect square trinomial? Well, p is squared, so p is the root of p squared. 5 is the root of 25. So then you have to ask yourself, is the middle term 2 times each of these roots? 2 times p times 5. And it is. It's 10p. So that is a perfect square trinomial. And we'll use the formula to factor that, which is simply add the roots, put parentheses, and then square the whole thing. In this case, are there any common factors? No. Are there any perfect squares? Yes. 49z squared and 9 are both perfect squares. The square root of 49z squared is 7z, and the square root of 9 is 3. So, is 2 times the roots equal to the middle term? 2 times 7z times 3, and it does equal 42. So this is a perfect square trinomial, only instead of a plus here, there's a minus, so there will be a minus there. In this case, we have a cube. That should be a clue. It's also a binomial. So it's not the difference of squares. Is it the difference or sum of cubes? Well, it's a difference. Is 8 a cube? Well, yes, it is. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. And for 64, 4 cubed is 64. And the way to detect cubes is to write them down at the beginning of your test. Say, start with 2. 2 cubed equals 8. 3 cubed equals 3 times 3 times 3 is 27. And you can decide what it is using your calculator. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125, and so on. You don't have to memorize it. You can just use your calculator, but write them down so that you can refer to it. So when you see a problem, oh, is 8 a perfect cube? There's 8. Yes, it's a perfect cube of 2. 64, there's 64. The cube root is 4. So then use the formula for the difference of cubes. Okay, on number 7, are there any greatest common factors? No. Are there any perfect squares? No. Is the coefficient in front of k squared a 1? No. So now we know to use grouping. And number 8, are there any common factors? Yes, the common factor is 2z. When we pull out a 2z, which I'll show you how to do this on the next video, you're left with this. So you have to go through the process again. Make sure there are no common factors that you missed. And then, are there any perfect squares? No. Is there a 1 in front of the z squared term? No. So you use grouping to factor this. So your answer is going to look like this. Okay, in this case, are there any common factors? Well, yes, a 9. You can pull a 9 out. And when you're done with that, you have x to the 4th minus 100. Are there any more common factors? No. is it a difference of squares? Because it's only two terms, so the only thing it could be is a difference of squares. Well, yes, the square root of x to the fourth is x squared, so it's important you realize that. And the square root of 100 is 10. So here you have a difference of squares. Your roots are x squared and 10, so you add them and subtract them. In this case, it's the same kind of problem, except do you have any perfect squares? No. Do you have, what do you have left? You have something squared plus something without a variable. You have a trinomial that you can factor, and your base is b cubed, so you have to be careful with that. You may want to replace, say, b cubed equals x, just write that down, and rewrite your problem as x squared plus 8x minus 20, which you can then factor using reverse FOIL. And then at the end, after you factored it, you go back in, and this will factor as x plus 10, x minus 2, and then you substitute in your b cubed for x. Everywhere you see an x, you write b cubed. And so that's how you handle a problem like that. But basically you're using reverse FOIL in that problem. Okay, in this problem, are there common factors? No. Is it a difference of squares? No, because these are cubes. So then you ask yourself, is it a sum or difference of cubes? And then you have to find out if 27 and 125 are perfect cubes. So we go back to the front of your blue book and we look here where you've written them out. We have 827 it's 3 cubed, and 125 it's 5 cubed. So now you have a sum of cubes, and you can use your sum of cubes formula for number 11. In number 12, you have this kind of thing. So we're going to look for a common factor. This is kind of like grouping. The common factor is d minus 3. So you pull that out and you're left with this, which gives you this. There's another common factor here, and that is a 2. So you pull that out and you're left with this. So again, let's review your steps. When we are told to factor something, we look for the greatest common factor. If there is no greatest common factor, or if we see perfect squares there, we may want to leave it alone for a while. The next question, are there special cases? Are there two terms, and if so, is it the difference of squares, the difference of cubes, or the sum of cubes? If so, you can use these formulas, but be careful. If it's the sum of squares, it's already prime and cannot be factored, so you leave it alone. Okay, the next special case again involves perfect squares. If there are 3 terms like this, and the first and third are perfect squares, then you run a test. You ask yourself, is the middle term 2 times the roots? And if it is, you simply ignore the middle term and write the first and third root parentheses squared. And that's a sum. If there's a sum here, it's a difference if there's a difference here. That's the end of the special cases. If it fits none of the special cases, then you ask yourself, is there a 1 in front of the x squared term? And if so, you use reverse FOIL. If there's another number other than 1, you use grouping. And so that is the step process you go through. There is one other case. If you have 4 terms, then you need to try grouping to see if that will work. And I'll demonstrate a problem like that. So now proceed to the next video, which is on factoring out greatest common factors.